Good morning, my name is Matthew Mormon. I'm an application engineer with Altec Industries.
I'm Carson Mullins. I'm also an application engineer with Altec Industries.
We're here this morning with the Altec Innovation Challenge. What the Altec Innovation Challenge is a competition among high school teams from around the county to come together and find problems that they want to solve in their schools, in their local communities, that they feel they have a solution for. And so we've had 32 teams come together and submit abstracts for proposals that they want to try to have implemented. So what they will do is they'll submit a project proposal, and then we as a engineering team at Altec will come back and review those. We will remove all the identifying information, and then we'll judge them off of the quality of the presentations. We had a really tough time judging all the presentations this year. They're really good, and then we came down to a total of 9 teams to compete today. So today we'll have the 9 finalists come in and compete on what their proposal is. They have submitted a project plan about the project, and they will then also present here to our judge panel to get the award of $10,000 to implement their idea in the community.
So we've got a panel of a lot of community leaders, people who are really involved in the community. They are here to see the kids' ideas and see their presentation, give them feedback, ask them questions, really challenge the kids to, do they know their project, are they prepared? And after today, we'll have the winner.
For this prize, we'll have a $10,000 prize. So this is allowing them to create a budget for this project and figure out what it needs to implement it. So we'll award the team $10,000, which will be used for implementing that. So we've done this in the fall semester of their classes. In the spring semester, they'll work on implementation. They'll work with us, the engineers at Altec. We'll give them resources as need be to help design or build their projects if they need help with that, as well as expertise in how to go about implementing their projects. We have projects from environmental impact to cleaning up waterways and getting clean water. We have different projects around how to reduce vaping in schools, and also how to be better on our environment. So we have teams that are looking at different ways to recycle and reduce waste output for their schools or for their programs in their schools. So we'll work with them once the winner is chosen to kind of help them implement that, give them some mentorship on that.
Welcome. I'm so glad to see so many smiling faces out there this morning. I want to welcome everybody to the 3rd annual Altec Innovation Challenge. I'm so glad you're here. I'm glad to see the students here with their smiling faces. They look like they're really prepared and excited to be here. Excited to see what you're going to offer us today. I'm excited to see the innovations. I'm really excited to see what you're going to bring to this audience when it comes to your ideas, your presentations, and your innovation. I also want to thank the school systems for allowing Altec to partner with you. It's so important for us to invest back into our community. We realize at Altec that the future of our facility and the future of this community really is investing back into the community and really investing into our kids. Making sure that they understand that there's ample opportunity right here in Hardin County. Right down the road, all kinds of opportunities, from engineering to business to manufacturing and the lot. Today, we're going to get the opportunity to see these kids shine. We're going to get to see STEM-related innovations that are going to show us and showcase the talent and the intellect that we have in this community. So I want to thank you for that opportunity, and I want to thank you on behalf of Altec. Over the last 4 years, excluding 2020, which we all know what happened in 2020 with COVID, over the last 4 years, we've had the opportunity to invest $30,000 back into this community. We're going to take another opportunity today to invest more, and so we just want to thank you for that, and we're looking forward to investing into our future. So with that, I'm going to get off this stage, but before I do, I'd like to just take one more minute and introduce our judges. So I got the opportunity to befriend a lot of the judges up here today, and they've been so gracious to take time out of their day and volunteer to come in and help us with the presentations and the scoring today. And so with that, I'm going to start with Kendra. Kendra Scott is Vice President with the Chamber of Commerce. Thank you, Kendra. We have Brian Kerr from Kerr Office Group, owner and operator. Megan Stiff, Chief Advancement Officer with HCEC-TV. We have Jim Owen. Jim Owen's also here representing Member Medical and Owen LaRue Financial. And we have Mr. Kenny Rambo representing Heartland Communication. Thank you all for taking time to help us today. So with that, I'm going to introduce our very first group. They're going to be talking to us about a water filtration system and they're here from Elizabethtown High School. So with that, welcome the kids to the stage.
Good morning. We are from Elizabethtown High School, and this is our 2022 Altec Design Challenge idea. I'm Kaylee Knight.
I'm Jake Rodriguez.
And I'm Camden Brangers.
And together we show us.
What is the problem that we've chosen to solve? The problem is that these recent months of storms and floods that Kentucky has had, there's not been enough clean drinking water for the homeless and low-income. So, they're having to get their water from lakes, ponds, streams, or even the side of the road. And that water it has bacteria in it, and when they drink it, it's giving them diseases. So how are we trying to fix this? We're creating a filtration system using two 55-gallon drums and a filter. The first drum that you see with the funnel is what's going to collect the rainwater. Then it is filtered out through PVC pipes. The filter is placed within the two PVC pipes. Then into the second barrel. That second barrel is what houses the clean drinking water for people to use.
Our design will conclude PVC piping, 90-degree elbows, a food-safe liner, coolers to store the water in, as well as a water spigot so people can get the water, and a waterproof nylon tarp. And our filter is the Clarify 12 disinfection filter.
Through our research, we were able to find that Elizabethtown gets, on average, 47.3 inches of rainfall annually, meaning that our system is able to collect up to 2,000 gallons of water a year.
Haley Fortier, Trevor Dybel, Matt Norman from Altec, as well as Andy Gaines, who is Vice President of Elizabethtown Industrial Foundation, Kaylin Thomas, who is a Dow engineer, and Matt Deneen, City Council member of Green Space, are all community members who have came in and spoke with us, given us positive feedback, as well as innovations to make our design better.
This is a further detail of our model. It'll be an enclosed structure made of wood, but we didn't make the structure today, so you all can see how the actual process is going to work. So we have the two 55-gallon drums, then our funnel, which collects the water, and then over here at the bottom right, this picture is showing the spigot on how the water is going to be collected out of there.
Total price for a single system is $1,621.81, meaning that with the $10,000, we'll be able to make up to five filters and still have $1,400 left over for any maintenance and repairs that might be needed. In our budget allocation, the three biggest expenses is our filter at $750, the wood that will be used at $500, and the cooler at $300.
Our design does not require any electricity, therefore making it semi-portable. Our design is also food safe as well as accessible to anyone. And when we say cost effective, we mean making it statewide. And the way we plan on placing them, they won't blow away in any storms.
The three biggest considerations that would be needed for the systems is possible breakage of the PVC pipes. So that means they cannot stay out in cold environments for too long. So we do plan on bringing them in during those cold seasons, which Kaylee has gone to Home Depot and she has found some sealant for the PVC pipe, which does let it last longer in those colder seasons. The sustainability, which because the system is cheap, you only have to really worry about the filter, which we would only need to change it once every 5 years. And everything else is cheap and easy to replace, where we plan on placing it at different like shelters and churches. There's even possibilities of just like they can do fundraisers to get those materials. And then possible debris getting clogged up into our funnel, which we do have a mesh filter at the bottom of the funnel to filter out any large debris and leaves, and be up to the filter itself to filter out any small debris that still could get in.
Thank you all for inviting us out here today. We really enjoyed working on this project. I hope you all have enjoyed it too.
Hey, team, hold on. Forgot to tell you a little bit about the logistics. So we're going to give them 7 minutes to present. Then we're going to give them about 3 to 5 minutes to answer any questions. So at this point, I'd like to ask if any of the audience or any of the judges have any questions.
Question. So you mentioned placing these at shelters like Warm Blessings or churches. Have you talked to any organizations about how this might work for them and any other needs they might have to be able to use the water and distribute it effectively?
No, ma'am, we have not. But the plan was it's an operation where it's all good. Like it can be ran by itself because it's the amount of rain that comes in and it filters it out through the next barrel. And then as homeless shelters or low-income people need that, they can go to the system and pump the water from there. It's not using any electricity, so we can just set it, place it.
Have you done anything to protect it from being vandalized or people doing things to it that they shouldn't?
Yes, sir. That was the wooden shelter I mentioned earlier that enclosed it. We just didn't make it so you can see how the barrels are going to work. But what that's going to do, it's going to enclose those inside, and then it'll be bolted into the ground, so then people can't come and vandalize it or mess with it.
So I guess the question I have, how often is the water tested?
We have a water tester with it, and then it's built into the system, and it's automatically testing the water. So we can just go and look at it like monthly or weekly, and then we can see the water, and if something needs to be changed, the water will be filtered, so we have to fix that.
It won't shut the system down if there's a problem.
No, sir. Because it's not electrically ran, the water is just manually filtered through the filter.
You listed in your research the average rainfall of 38 inches annually. Are there months where the system would not see enough rainfall?
It would be probably June, because that's one of our hot seasons. There's not as much rain during June, but the 47.3 inches of rainfall is averaged across the whole year. And that's able to give 160 people of water per year, and that's them drinking water every single day. So that's the average human amount of water they drink. And we'll be able to feed or give people water 160 throughout the whole year, and then drinking the water every day. Yes, ma'am.
How often would the funnel have to be changed?
The funnel's made of a ripstop Allen tarp, so I don't know if any of y'all have ever been camping or anything, or seen tents. It's made of that material, so we can check on it yearly to see if there's any drips or anything in it, but then we'll be able to fix it based on that.
Joe, put much consideration into like excess water as far as being able to swap out the 55-gallon drum?
Well, what we have is that there's going to be a check valve on the first system that collects the rainwater. So then if it does overflow, it'll go off the side, but then we won't have to filter out clean drinking water that's already been filtered.
And then what's the funnel material made of?
A ripstop Allen tarp.
You said there would be how many? You think you could purchase 5, so they would be distributed across the county or just in Elizabethtown?
Just in Elizabethtown for right now, different churches and like Warm Blessings, places like that.
Any other questions? All right, thank you all. Great start. Good job, you all. All right, now we're going to welcome to the stage a group from EC3, and the presentation title is Bustly. Be interested to see what this is about.
Hello, my name is Elisa Melgar, and I'm the team leader for the project, Bustly.
Hello, my name is Ron Zachary. I'm the assistant to the team leader.
My name is Jalen Johnson. I'm the lead researcher.
My name is Simeon Bonner, and I'm the assistant to lead researcher. My name is Michael Van Vizer, and I am the co-president.
So the problem we're addressing is that many students riding the bus often have difficulty getting to the bus stop on time. Often there's no way to know if the student is running late, unable to ride the bus, or taking the car to school. Because of this, it makes the buses late to school, and they'll often have like varied times as to when they get there.
The solution we came up for is Busly. This app will be able to inform students of its condition and where it's currently located. It'll give students ETA times, and as I said just now, it gives its current location. In addition to this, the parents of the students will be able to inform the bus driver if the student's not going to be at the bus stop or if they're going to be riding a car or something akin to that at school, giving them smoother, more efficient bus ride.
Advantages and disadvantages. Advantages are you and your parent can know exactly where your bus is and how long it will take to get to your house and school, or wherever you are being transported. Disadvantages for this app, we may not have the materials.
Another advantageous piece of our project app would be the cost, as the only expected expense would be labor. All other concerns such as tools and materials go to free. So from March 1st to 31st, we would hire a team of software engineers or a software engineer to help us develop our app. From April 1st to 7th, we would test and debug the app for anything that could possibly go wrong. From April 8th to 18th, we would clear the app for iOS App Store and Android Google Play. And then from April 19th forward, we would release the app for all users.
We know that every guardian does not like when a student misses the bus. It's just a hassle. You have to drive them in, and if you don't have any driving in, they have to miss school, which leaves a mark on their attendance. This app plans to make that inconvenience, well, convenient, because it'll lower those rates and, it'll make the student's life easier as well as the parents. Thank you for your consideration. This has been Busly.
All right, team, thank you so much. And with that, we're going to open up the questions. Anybody have any questions for Team Busly?
For this app.
Grab that mic.
What's it going to cost to develop that? Keep it going.
All in total, roughly, of course, $8,000.
You mentioned the app uses GPS to track the location of each bus. Do buses in your district already have GPS installed, or would that be an additional cost?
Yes, all our buses in our district, and I think according to our research, every bus in the surrounding district also has GPS tracking.
Is there a cost for consumers to actually purchase the app for the parents and students?
No, this is purely for.
Are there any comparable apps currently out there?
Yeah.
The closest thing you can find is something akin to like Uber or Google Maps, right? If you look at Google Maps, they, can you click back to the slide? My slide. The general basis of it is it'll have like a route of which the bus uses and a little tidbits akin to like Google Maps where you can put little place markers of where it is will be the students, which is also goes back to the being able to remove it if students are not going to be there. And so it's like similar to that.
Good morning. Did you guys give any thought or consideration to privacy concerns for the users and basically putting the information out there of when your kid's going to school or not going to school?
As you can see on the slide, it actually has, you have to have the student ID information similar to how Infinite Campus works. You have to have all of that. It's not just simple ID scanning.
Any other questions?
I just had one more follow-up question. The price, I don't know how much it costs to develop an app. So the budget you developed, where did you find that $8,000 estimate, or was that based on similar projects?
Our resident student coder, the student in Cameron Hall from our coding class, gave a rough estimate, of course, for the development of the app, upgrading of software and things like that, and came to roughly $8,000, $9,000.
In addition, we do also plan on using the student body, like their IT team at EC3, to help develop this app, which cuts the cost much lower.
Did you guys explore at all the possibility of delivering this through progressive web-based application versus a mobile app?
You're talking about like a website?
Primarily what we call PWA.
The original plan was 4.5 years.
Thank you, guys.
Any other questions?
All right, thank you all. All right, with that, I'd like to introduce a team from John Hardin. They're going to be speaking to us today about connecting the community.
Good morning. We are John Hardin High School Beta, and this is our Altec Innovation Challenge proposal, connecting the community. As previously mentioned, we are from John Hardin High School Beta. Our club focuses on leadership, character, service, and achievements. We are made up of sophomores Kenneth Ritchie, Anna Dawson Hall, and juniors Isabel Moore and Jeremy Selby. Our solution is split into 4 main components: the problem, the solution, the plan, and the impact.
So first things first is our problem, which is the struggle to find community service. And this goes 2 ways. So the first way is from the nonprofit organization struggles, how they struggle to find volunteers to help them. And we see this a lot in the Beta Club. They try to come and get us to volunteer, but usually it's too late trying to find the right connections to get to people. And it's usually just not too far in advance, so they struggle to get people help. And then from the student perspective, we like to do community service, to get those enriching experiences. It looks great on college applications. We like to gain perspective outside of our own, and it's a requirement for our club, so we need it. But we struggle to find willing, safe places to go to, especially after the pandemic, places that are just willing to take us. And Jeremy will tell you guys our solution.
Our plan is to develop an app. This app will mimic the event planning portion of Facebook. As you may know, on Facebook you can see the details of an event, who's planning on attending, who's interested, and who isn't interested. We plan on taking this idea and merging it with a layout similar to TeamReach or Google Classroom. Another important idea we had for this was relevance. We know how social media oriented students are, and we wanted to have it more relevant for them to use, so we have it set up in a scrolling based method like Instagram or TikTok. And here's Kenneth with more details on the stats.
So next is the plan on how we're going to build that. As Jeremy had said, we are trying to make this social media based. So we did have a prototype prepared that would do the same thing as this app is presenting, but we sadly cannot bring that with us because the software we used to build it ran out of storage space. So the prototype is therefore incomplete. But through building the app, we are hoping to connect with Altec's app development team, since we cannot do it ourselves entirely. And if not, we are going to have to enlist the help of an independent app development team to do so. We're hoping to collect our money from Hardin County's grant division to, of course, to get the money for our app. And if not, we're also going to pick up money from smaller fundraisers and so on. All nonprofit organizations we use, though, will have a 501(c)(3) from the IRS to ensure that they're safe and secure for all involved. There are 3 different user interfaces to our app. There is the nonprofit organization, students, and educators. The nonprofit organizations will get a chance to post how many volunteer hours they need and what service they need done. And the students will be able to sign up and say, hey, I would like to do this event for this many hours and that. And then the educators are almost like our middlemen, where they will then say, hey, students, you can go and do this, and they come up with how many hours each event. But every student must be verified by both the school system and their educator in order to enact on the volunteer hours. So our total budget, we're expecting this to spend about $20,000 altogether, which 65% is going into building apps. That's getting the software, any help that we need, running apps and programs, all that stuff. And Then 20% is going into maintenance, so that's updating the app after we made it, small bug fixes, making it more accessible to more people. Then 10% is going into training, so that's training the nonprofit organizations on how to use the app, and also training educators on how to use it. We're going to cut costs on this through also having the educators train the students on how to use the app. Then the 5% that's left is going into marketing. That's going into making sure that other nonprofit organizations understand how to use it, and also making sure that other school systems know how to use the app.
And the final step to our plan is the impact, and that this app will have impact for years to come. Not only does this give students an organized way to keep track of their hours, it also ensures networking to happen between different schools, clubs, teams, and nonprofit organizations. Our community is growing and there are needs that need to be met. And we believe that with our solution, rooted in STEM, we can help in different ways. I will now leave you a quote from David Spankler. Some people think they are in community, but they are only in proximity. True community requires commitment and openness. It is a willingness to extend yourself to encounter and know the other. We hope this quote inspires everybody in the community to come together to solve one problem. Thank you.
All right, do you have any questions for the team?
So what was the thought process to limit this to students and not to the general population?
So we limited this to students just because the general population already has apps and services that can allow them to get out into the community, but students find have the most struggles in doing so.
And also because what we previously mentioned, this was doing college applications, and especially as high school students, they want to get those extra hours, and also Beta Club also, you have to have a certain amount of community service hours to stay with the organization.
So my question kind of, you might have already answered part of it, but how is your platform different than other options that are out in the market? And have you seen anything like this in your research?
I haven't seen anything like this. This is just strictly kind of like for schools to kind of get into the community service, you know, just to help those people who struggle.
So sustainability, and so once you all graduate, who's going to do the updates or keep up and maintain the app going forward?
So we're hoping that whoever we enlisted to help us build the app will be able to maintain the app for us, as long as also a beta team or one of our members would help them with it to continue the app in its place.
Are there any other questions?
All right, thank you. I think I'm going to go ahead and introduce our next team. And our next team is actually the first repeat that I remember of. This team has actually joined us before, and they're coming back for a second shake at it. And we're excited to have them. This team is going to be talking to us today about the autonomous, autonomous waste collection boat. Call themselves the Boat Boys. So welcome to the stage, the Elizabethtown School System Boat Boys.
Good morning. My name is Sage Garris, and this is the Altec Innovation Challenge.
I'm Tay Wooten. I'm Carter Peace.
I'm Conley Crossnow, and we are the Boat Boys. The problem we are looking to solve here today is man-made topwater pollution, such as bottles, cans, plastics, and all sorts of debris. Not only is this pollution from people dropping trash in the water, but it's also from runoff pollution that comes from the roads and the parks. We are just looking to clean up all the water and make all the lakes and ponds a lot cleaner. We have firsthand seen this at local lakes and ponds such as Freeman, Salem, and McDougal. We just like to clean up the area.
2.6% of the world's water is fresh water, and here in E-Town, Freeman Lake is one of many drinking supplies.
So what are we doing to fix this? We have come up with this autonomous waste cleanup boat, and I'm going to step down here with the judges really quick to point out some features of our boat. We have the conveyor belt to actually pick up the trash. This has ridges so that the trash doesn't fall off. We have a waste collection bin that has proper drainage. This will either be a mesh bottom or a net bottom. We have pontoons and a propeller for low water contact design. We will also have solar panels and an auto docking feature. Our boat built into the budget will come with its own dock, and it'll have load sensors so that when the boat is full, it will go back to the dock and send an SMS text message to whoever's in charge of the vessel, which we'll talk about in a little while. Again, here's our prototype. It's in the water. The conveyor belt sits about 2 inches below the water so that the trash is actually scooped up instead of bouncing off the front. This is small scale. This is our prototype. You can see it working here. This is our prototype, and large scale, it'll be about 5 foot wide by about 10 foot long. It'll have a 5 foot by 6 foot by 1 foot deep collection bin, so you can think about the amount of trash that'll be able to pick up.
So for research, we have spoke to Matt Deneen. He is a member of the City Council in Green Space. We have spoken to Altec engineers and Dow engineers such as Trevor Dybel, Matt Mormon, Haley 48, and Kaylin Thomas. We've also spoken to Andy Games. He is the Vice President of the Elizabethtown Industrial Foundation. We also called Freeman Lake volunteers and told them about our idea, and they would love us to implement it into their lake. As of right now, there is no fully autonomous boat like the one we're trying to create right now. We're kind of basing ours off the Roomba.
So like I said, the point of this is to clean up our local lakes and ponds. 94% of the United States water is contaminated with microplastics. These have been linked to various health concerns, hormonal malfunctions, heart disease, lung disease, and various cancers. If we can get to the plastic before it has a chance to degrade from UV or other weather patterns, then we can minimize the microplastics in our water. We will put our first boat in Freeman Lake. It'll be 1 unit per body of water if we ever expand. It will need to be emptied when full. This can be done by a worker or volunteer. If Beta or National Honor Society, which I know that E-Town and LaRue both offer, if they need service hours, we could implement this into their organizations. It'll need to be emptied, like I said, when it's full. This will be weekly or daily, depending on how much debris there is in the water. And here is an example of our autopilot software. We're going to use ArduPilot, which is an open source and free software to use. And this is Freeman Lake mapped out. That's kind of the path the boat will take.
If we're fortunate enough to win the $10,000, in total we'll spend about $8,500. Majority of our costs will go into the manufacturing, pontoons, and the software for the autopilot, which will leave us with about $1,500 for any maintenance or repairs.
Like I said, this is helping keep our local lakes and ponds trash free. This is, as was said, a 2-year project for us. We started this last year, and we've come a long way. We all know this project well, and we've stuck with it.
Something I've heard a lot throughout my life, and a quote that has really stuck with me, is slow and steady wins the race. As you may be able to tell, if you were here last year and you've seen this boat, we have came a long way. We have a full working 3D printed prototype right here, and last year we came in with just the conveyor belt that was basically a glob of glue and some plastic thrown together. So we've came a long way with this, and if we were fortunate enough to win this $10,000, we would make this a large-scale product that would clean up all the trash in these local lakes and ponds, and it would have a great effect on our environment. Also, I would like to add that our boat is powered using solar energy. More specifically, we're going to have 2 100-watt panels to power it, as well as a DC motor for clean energy. So in conclusion, this is a green solution.
All right, any questions for the team?
I love that you stuck with this idea and adapted over time. So can you tell me what the most important lesson you've learned so far through this experience has been?
I think the most important lesson we've learned is, honestly, to never give up. We are fortunate enough to have some resources at the school as 3D printers, and we designed this entire product. Again, last year, we had the resources, we didn't use them. So using them this year, not giving up on it when we didn't win last year, it meant a lot to us. You know.
Great job, and thank you all for sticking with us. We really respect that. So my question is, where is the collected trash going to go? Do you plan on recycling those materials that are then collected, and who's responsible for that?
Well, that would be pretty easy. When it's emptied, it'll have gas struts, so it'll dump itself out into a dumpster that easily can be recycled. It may need to be sorted because I'm sure we're going to pick up some other debris, wood, some leaves, things like that.
And how fast does it travel? Sorry.
It doesn't travel very fast at all, actually, and it runs about half the day. It charges when it needs to. It runs at night. It'll have batteries on board to store the energy, so it'll be pretty slow moving, and it'll just make its rounds.
So the idea is that it would run after the park closes?
Correct. It'll have lights and other safety features.
Good morning. So tell me a little bit about what happens when software or some sort of debris catches the boat out in the middle of the lake.
If it gets stuck,
You got it.
so we thought about programming in like a 2-hour time. If it doesn't move, and it's trying to, within 2 hours it'll send a text message. Whoever's in charge of the vessel can go dislodge it in a kayak, john boat, any of those.
To that point, sorry, who is in charge and how is that determined?
Like I said, we can either hire a worker with our surplus, or if a park volunteer, Beta National Honor Society, if one of those volunteers wants to take charge of this, or one of us, we'll still be around. So if we determine a couple people who will have the messaging link, then we can send those messages.
At the bare minimum, me and him are both part of the Beta, and he's part of the Honors National Society. So, bare minimum, one of us will help maintain it and run it, and we would be glad to do it, especially for the community.
Any more questions from the judges or audience?
Thank you. Good job, guys.
Thank you.
Boy, you gotta love tenacity and grit. I love it. We'll take a couple minutes for the judges to be able to make some notes. I'm always amazed when we come and do this every year. It always amazes me to think about these kids and how much foresight they have and how much they challenge themselves to be good community stewards. You know, if anything else we get from this is just seeing and being encouraged by the fact that our community is in good hands. I hope you get that from today. So with that, I'm going to announce our next group. Our next group is from EC3, and they're going to be talking to us today about trail enhancement and a proposal they've got for that. So with that, I would wish you would welcome the EC3 team to the stage.
Like we said, we're from EC3, and this is our trail enhancement proposal for the Altec challenge. My name is Dawson Brown, and these are my colleagues, Jackson Kist, Thomas Ray, Zach Spurrier, Sandra Lucas, Cooper Clark. All right, so what is our problem? We wanted to create an idea that benefited our community. One unique thing about Hardin County is the amount of trails that we have here. We have over 100 miles of trails, but in addition, the majority of people don't know how to properly stretch on those trails. According to America's Health Rankings, 30.6% of Kentuckians are physically inactive and do not know the importance of stretching. According to Harvard Health, when you don't stretch, your muscles become tight and undergo to function. Our solution to this problem is to build a stretching station. The stretching station would have multiple ways for you to exercise and stretch your limbs. That way you can be more limbered up and ready for the trail.
Through research, we found that stretching stations are very scarce in Kentucky, and we were able to locate one. It was EP Sawyer Park, located in Louisville, Kentucky, and it gave us a great picture and ideas of what we wanted our stretching station to be, and we found many ways to improve it. So this is EP Tom Sawyer Park in Louisville. And one idea we liked from this is it provides how to do the stretch and gives great examples.
We talked with Seth Breitner, who is the director of parks here at E-Town, and as we met with him, he loved our idea for this stretching station, and he said that the best spot would be the north side of Freeman Lake, because it is the most congested part of Freeman Lake, and it's the trailhead there. And as you see, there's a satellite site overview of Freeman Lake Park is the north side, and here's a closer view of where the 25 by 25 concrete pad would go for our project. And here's our on-ground research here, actually measuring out the concrete pad for it.
Concrete pad will be 25 by 25 bays, and all of the equipment will be bolted onto the pad. It's going to be divided into 3 sections. There's going to be the area for stretching and all the equipment for that, and then a bench and trash can, and then a bike repair station that we decided to add later in the project. 3D models of the stretching stations have been made to show you an overview of what they're going to look like, and the material for the actual equipment will be made out of high-grade materials so that they don't weather over time. Here's a look at some of the models of stretching equipment that will be used on the pad. And there's some more.
During our meeting with Seth Breitner, head of Parks and Recs, he suggested the bike station, and it will consist of an air pump and a set of tools that will be used tether to prevent theft, and it will be used with a 5x5 pad. And the cost of the bike repair station will be from anywhere from $700 to $1,200.
So these stations will be very sustainable. Industrial grade material will allow the stations to withstand many weather conditions or aging. If vandalism or issues as like people trying to take them or whatever, Park and Rec will manage that and repair the damages that come to them. And Park and Rec will also have control of adding or replacing certain parts based on feedback from their community.
And then our budget consists of $1,200 for the bike repair station, and then we've estimated with Altec engineers we have 5 parts for the stretching part, and that will equal $3,100. And if we have 2 of those, that'll be $6,200, which leaves us roughly $3,000 for the concrete supplied by Parks and Rec.
Any questions or concerns?
So with this being an outdoor type project that might not have to be stationed at it constantly to monitor, how would you measure or define success and know that people were helped by this project?
So we thought about starting a Facebook group or a page and hearing feedback from the community. And we also talked to Seth Breitner about implementing that.
Have you all thought about how many people actually use it, or done any research on how many people actually use the stretching or build for either the walk exercise?
A lot of people who go to trails either don't know how to stretch or don't have enough adequate equipment to stretch. So this would provide a resource for them to actually stretch on the trail.
Also, we talked to someone on the cross-country team, Sierra, and she said that the cross-country and track team would definitely use these a lot in their running.
Any more questions?
You've done any research that says it's highly durable and all that. Any idea how long the materials would last before any piece would be replaced?
We estimate with weathering a couple of years, or if any bad storms, and Parks and Rec would manage all the repairs. Any more questions from the audience?
Would you all actually do the installation?
we'd contact Parks and Rec about that, Seth Reitner. So we'd be more than happy to be on the ground when it does. All right, thank you.
We're going to bring up another team from the EC3 campus, and this team's going to be speaking to us today about drip irrigation. So with that, I would like to welcome that team to the stage.
Good morning. My name is Landon Johnson. This is Angel Evangelista, Raina Smothers, and Jake Atcher. And today we are doing drip irrigation system.
The problems that we have noticed in our community is water conservation, water contamination, and plant maintenance.
This is a map of our drip irrigation system to fix these problems. Our irrigation system will cover these dead plants to cover it for EC3. They'll be placed vertically as shown instead of horizontally because of the pipe sizing. 1/4 inch pipes can only cover about 75 feet, a little bit more, and you have debris and other particles and sediment causing cloggages. And an irrigation system this big will definitely give the students at EC3 enough food for the lunch, which would be healthy because plants to give the agricultural class a nice little project. And if they want to expand it, it'd be for homeless people too. So it'd be something for the ECTC campus to remember. This is EC3. Irrigation system would be to the right, around that building. This is a diagram of our irrigation system. First, I'll go over the water source. There are actually 3 city water sources around EC3, so we don't have to worry about rainwater or something. We can just get out of the city water, poke holes in the pipes, and connect it to our irrigation system, which is more important, as you'll see later. The water pump pumps water from the city water and gives it throughout all our irrigation system. It is required because of our irrigation system's size. If it was smaller, you could have stuff like drip tape, but ours is too big for that. Timer. It simply decides when the water goes to the plants. So this saves time for the staff to maintain stuff. If they leave it running, this would also, it just saves time and money. The filter and the timer are irreplaceable. The filter will probably go before the timer because we also plan to filter the city water for reasons I'll go over later. The filter, we might need 2 filters because the city water main just run in one direction towards EC3, so we have to do other things and have our own pipe actually only cover sediment, so it shouldn't be that costly. And for the contaminants in our irrigation and the water supply that goes to EC3 has arsenic, nitrate, chromium, several haloacetic acids, several times, up to hundreds of times, but only for haloacetic acids, over guidelines set by environmental working groups. So it would filter the water going to people drinking it out of the fountains and would go to the plants, which may contain these chemicals. Some of them are proven to make this stuff. Fertilizer. Our fertilizer injector will inject fertilizer to help the surrounding environment, the dead plants. A concern may be that too much fertilizer may harm the environment around it, but due to drip irrigation's steady water supply, just dripping water around the area to be irrigated, it shouldn't be that much fertilizer and not a problem at all. Last week we addressed the issue of pressure. We'll place a pressure regular at the start because city water flows at 40 to 85 psi, which is not optimal for our irrigation system's 20 to 25 psi recommended for drip irrigation. We will also place pressure compensating emitters to lower the PSI needed in our irrigation system. So the water pump will use less energy and have an easier time, and we'll save more money.
So the solutions we came up with was water conservation, water contamination, and plant maintenance. So for water conservation, it's how the system works, like it's the amount of water that is usable and it's less used, like so we don't use too much. Water contamination, there's many dangerous chemicals and hazards in the water that is very dangerous for us to consume. Plant maintenance, the drip irrigation system will help reduce the amount of water that is used on a daily basis so that too much is not used.
And these points make our system, like, it stands out in these ways because it's not hard to keep the system running. So if we were to go through with the system, then no one would have to worry about it breaking or come to check on it all the time because it's self-running, it can do it itself. And I believe that if we were to do this at our school, then other schools might follow, and then we can, the benefits of the system, they can spread over a larger region. And then next is we are solving issues outside of our here, and that's very important to us because we want to do more with this. So we're working towards solving global problems, which ties back into other schools also having, or they might follow in our footsteps. And then next, the money that we put into this system, it won't be lost because it's low maintenance and it also saves money and labor. Any questions?
Can you explain for me the difference between this and just a regular irrigation system you have at your house? What's the difference?
So this system, it works for larger landscaping. So instead of like just spraying water, it drips it. So it saves water and it also keeps the plants healthier because it doesn't just soak them and leave the soil like overly saturated.
Notice this year's size of it. We're trying to make drip irrigation as optimal as possible for our circumstances. For example, what it was going to be made out of, the main line is going to be made out of PVC because that's just the city line. But our actual drip lines will be made from UV resistant resin, or UV light resistant resin. So that sunlight will not damage it, and it can be visible to anyone coming to EC3, so they might think about it a little bit.
Question, who will be responsible for actually installing the system? Is that your team? Is it the school district? Who will actually make sure it hits the ground?
A combination of the two.
Will this be a system you all fabricate from scratch, or are you planning to purchase it from another provider?
Yes, we've already found all materials from providers that we need. Because many people already install irrigation systems at their home. So, the market's simply designed for people to purchase these materials and build it themselves.
Any other questions? All right, thank you. All right, our next group coming to the stage is going to be speaking to us about a fell fill extruder system. This team is coming to us from Elizabethtown City Schools. welcome to the stage. Make sure you speak into the mic.
Hello, I'm Zachary Prestis.
I'm Jason Towell. I'm Hendrik Songs.
And I'm Gavin Brunig, and we're from Elizabethtown, and this is our Altec presentation. So the problem that we have identified is lack of recycling in our community, our school, and this is a worldwide problem. Lack of recycling is an issue in communities all around the world, and our community is no exception. A lot of the recycling just ends up going into landfills anyway, not being recycled back into production like it's meant to. Another problem we identified is a lack of a sustainable 3D filament process for our schools. So, for instance, our school, 3D printing is a big part of our engineering program. As you can see with the business card holders we have given you all today. We 3D print all the time, and there's no way for us to sustain the filament we use to create these things, and it can end up being very costly as time goes on. So our solution to this is to purchase a fell-fill extrusion system bundle.
With these bundles, we will be getting an extruder, a spooler, and a shredder. These bundles can be used to recycle plastic along with old prints and supports that are used when printing. When we print, we obviously have a lot of waste because there could be failed prints along with supports, so those can also be recycled. These bundles are trusted by SpaceX, the University of Maryland, and ShareBot.
So the first step in this process is the shredder. As you see in this picture, we have 4 different types of blades that go into the shredder, so we are easily able to shred hard plastics, light plastics, being most efficient as possible. At the top, we have our hopper, and the plastics will be directly inserted after being cleaned. They will be shredded and then dropped into the bottom tray. And then after that, it will go into the extruder. At the top, we have our hopper. Talking to the Altec engineers, we have come up with a great idea of expanding our hopper size so we can import more material and output more 3D filament. We are going to 3D print our own hopper and set it on top there. And then it is also customizable by temperature. Different plastics melt at different temperatures. That way we can have a high quality of standard. Lastly, we have the spooler. On the left, connected to it, is our fan. When the 3D filament is extruded out, it is rather hot and we want to cool it down so it is not melting on the spool. On the right, we have the actual spool. This is a continuous process, so as long as 3D filament is being extruded out, the spool will continue.
So some of the plastics that this machine is able to process are your major plastics such as PLA, ABS, and PET. Those major plastics are found in everyday items such as toys like even Legos, plastic water bottles. And this machine can also process other plastics like bottle caps and even can process some phone cases that can be recycled.
So with the budget you all are giving us, we are planning on purchasing 3 of these bundles. And the one bundle includes all 3 of those machines. That would be 9 of those 9 machines in total. And we're planning on purchasing recycling bins to place around our school, our community, and we've also looked into expanding to other schools, placing recycling bins around their community, or their schools, and gathering the plastic from their schools and then perhaps selling filament back to them for a reduced price for what they're buying now. We've also talked about expanding this to local businesses that might want to use 3D printing in their businesses and selling filament to them for a reduced price as well. We talked to the owner of the makerspace at the town mall, and he said he's been doing a process similar to this for a really long time, and he said that he thought it was a great sustainable way to introduce 3D filament to our schools, our local businesses, and our school. And this is our budget. As you can see, the majority of it is taken up by the 3 bundles. But we've also allocated money for recycling bins, as I said earlier, to place around our schools and our communities, a dehydrator for $150 to take water off of the different plastics, and that would increase the quality of the filament coming out of the extrusion system, acetone to remove labels and other debris that might be on the plastics, again to increase the quality, and over $1,000 for maintenance in the future.
At our high school, we have 2 engineering rooms along with the construction room. The construction room has recently been getting pretty full, so the high school has given us permission to expand and put a new room, as you can see. In this room, we'll have things like our CNC machine, laser engraver, Glowforge, and mini 3D printers. This is a 3D model of this room. As you can see, we will have plenty of space to put these machines, along with, if we wanted to buy more machines, we could have room for that, for expansion.
So some of the community research that we have done is spoken to 3 different Altec engineers who provide us with valuable feedback and suggestions, such as increasing our hopper size in order to input more material. We have also spoken to Andy Games and Matt Deneen, who are both prominent leaders in the Elizabethtown community. And Andy Games has even given us the names of 2 people that are very big advocates for recycling and manufacturing, as well as we have spoken to Caleb Thomas, a Dow engineer, who has really told us about the importance of sustainability in manufacturing.
So talking to Caleb Thomas, mechanical engineer at Dow, sustainability is the biggest thing in the manufacturing world today. Our machines are very sustainable, as 100% of the material that are input are outputted for this machine. This machine will run 150 grams per hour, with the average spool of being 265 grams. Every 2 hours, we can make an entire spool of 3D filament. With 3 machines running for the entirety of the school day, we can at least make 10 entire spools of 3D filament. We will be cycling through machines and shutting some off so that we can keep maintenance costs low so that we're not overheating the machines. In conclusion, we can turn this into this, into this. Thank you.
All right, any questions for the team?
It sounds like there's a few steps involved in the process in cleaning and preparing material and then running it through the melting and then re-spooling. So who is actually going to be managing that process day to day?
So the majority of that labor will be done by the engineering program and students in that. Our teachers trust them. We trust them with the machine in order to do what is right with the machine. And also, I forgot to mention this. This is on one of the slides. The EHS Environmental Club will also partner with us in order, they will help with a lot of the manpower if they are willing to do that. And we might be able to offer, if we're really lacking labor, offer beta hours for people who are willing to help us with this.
The really beneficial thing about this new hallway or engineering room is it's only run by the engineering students. So this machine, the people that are running it are engineering students. They will be trained. So we'll have complete security over this.
You'll be creating your own fulfillment material. How much does the school, what's the cost per year to the school as far as when they're buying brand new as compared to savings you're going to create with making your own?
So right now, we purchase around 20 to 25 spools of filament, each costing $25 to $30. So that's a lot of money we spend on 3D printing, and we go through that around 3-4 months. So yearly, that really adds up. So creating this, not only we can make our own 3D filament for free by recycling, we can also make money through our plan to sell them to businesses and sell them to other schools for reduced prices.
Any other questions?
How do you control the color?
Okay, great question. So on the Fairfield website, where we're purchasing from, they have pellets that are colored that we will also be purchasing. They're around $40. There's 3 different types that they have on there. And it's around 8 pounds of pellets. So those will actually be mixed into the plastics we put to color them. And a small, very small percentage we put in, so that will last us for a very long time.
You covered the different types of plastics that can be recycled using machines. Is that blend then used in the filament, or do different input plastics result in a different filament coming out?
The filament should end up coming out about the same, but mentioning that, I would like to touch on that we will not be mixing the plastics. So if we have PET running through the machine, we won't insert PLA until the PET is run through the machine, because that could cause damage because they do melt at different temperatures. So one spool will be all made of one plastic, but all the plastic quality should be about the same.
All right, thank you. Good job, guys. Good job. And so we're going to welcome up another group from EC3. This group's going to be speaking to us today about e-cigarette detectors. Welcome to the stage. Make sure you speak into the microphone, okay?
Hello, we are EC3. I am Anaya Ellis.
Tristan Williams.
I'm Marquise Smith.
I'm Alex Carrier.
I'm Zay Lowry.
I'm Noah Claxton.
And we are SOS, Sons of Strategy. We are here representing the AP Computer Science and Computer Hardware class, and we are here to bring to you the vape detector.
E-cigarette use amongst middle school and high school U.S. students has gone up 900% in 2011 to 2015, before declining for the first time in 2015 to 2017. However, current e-cigarette usage increased 78% amongst high school students during the past year. Usage has went up 11.7% to 20.3% in 1 year. Locally, in adults, 6.1% of Kentuckians use e-cigarettes, plus 7.4% use smokeless tobacco. In children, such as high school students, 26.1% use vapes and has risen to 32.7%.
In schools, students often vape during classes, in between class changes, in hallways, bathrooms, and in crowded spaces. Vaping is heavily advertised as a good alternative to cigarettes. However, teens are unknowingly creating health problems such as cancer, popcorn lung, pneumonia, etc. We discussed that we would put at least one vape detector in each bathroom. Vape detectors alert the proper authorities in the establishments so they can handle the situation as deemed necessary. The product would run off of PC, AM, Bluetooth, so no heavy installation is required. Only the admin will know it has gone off.
To research the product, we researched already existing vape detectors. We had in mind to make our product better than others. We would make our product more accessible for the low-income communities to get a hold of. We would also have an adjustable sensor strength and distance with an 8-year guarantee without maintenance.
We were thinking about putting about 8 detectors per school so they could test out the product. If they would want more, we would give them more because we would buy about 50. Buying about 50 products would be about $3,500. Each device is about $70 plus a $14 charge for the 5-pin USB connector that needs to be connected to the product.
The design of the vape detector is a very small square, about 4 inches, with Bluetooth-like network sensors, which were chosen for easier installment, will cut costs significantly. The sensor inside will detect metals, unusual chemicals, nicotine, and other chemicals. Each vape detector is marked with its own serial number, plus will display when set off in a string appearing saying smoke detected or vape detected, plus in which bathroom where it is when VSD is enabled.
I spoke with Laugh Tabs of Technology Director of Hardin County, and he said that they were also previously trying to put vape detectors inside schools, but they were not compatible with the school's networks. Our product is compatible with the school's networks because it runs off of PAM and also PC. So it can connect to a computer or a network system to any school at any network at any time, and it'll be on time, accurate data, and fast giving. We will buy our products from Newark and Newegg, which are very well-known companies to buy products from. They are also approved by Marks Hardware, which is another credible site to give electronics from.
With particle sensors as sensitive as ours, it can even detect whenever it's covered, and it will send a notification to the admins or anybody that has the authority over it that it has been covered. It works by using a particle scanner to scan the air for chemicals like the nicotine and iron, and it scans the air for contamination. Vape detectors use 3D sense work by using particular sensors to detect the presence of vapor in the air. The ideas of vape detectors are to go unnoticed to protect dissents, particle changes. The differences of smoke detectors as they are to alert everybody that there is smoke in the area. Vape detectors, on the other hand, are supposed to be discreet and alert only the admins. Our sensors have an adjustable range so it can be fitted in any bathroom and can adjust the sensitivity adjuster so you can make it sensitive as needed. Each device comes with its own program that can be downloaded to computers and will tell you where the vape is located in the location of the bathroom and all. It comes with admin keys and computer codes so anyone, no matter the level of experience, can adjust the device.
Additional things we will need are boxes plus packaging, which will be provided by Newark. We'll need the correct certifications plus a business plan, which are also provided by Newark, and an estimate from each school on how many they will need or want.
So the strengths are, it helps decrease developmental issues in students due to vapors. Monitors air compounds levels in schools. It has adjustable sensor strengths and adjustable length. And the only weakness is student vandalism.
We will be selling each product for about $150, which is considerably a fraction of the price of already products that are on the market. But you're selling for $2,000+ per item. Each school will be able to test trial the products to see if it actually works for their school environment and to see if it actually is a good fit for their school. If they would want more, we can give them quotes on how much each individual product would be. While other competitors have raised their price about 100% of the actual price to make the product, we have made it our goal to make it as accessible as it can be for each school and each community even. We are SOS, Sons of Strategy. Thank you for listening to our presentation.
All right, any questions for the team?
Yeah, so first question. So you're actually developing this device, or I guess this is clarification, you're purchasing a completed device?
The device is not completed. The sensor that we are buying is just the particle sensor. And we are also buying different parts to connect to the particle sensor where the sensor itself is made, but the product is that we are making the product.
So if the goal is to intervene as the student starts vaping, do the schools have capacity to follow up with all the notifications they may get throughout the day, or have you talked to the schools about whether this is something they can manage?
Each school in Hardin County actually does have a officer on hand in the schools, whether it's 1 or 2, and school admins also use bathroom duty along. So each admin will have an alert on their phone or on a walkie-talkie because it does run off of AM and PM, and so any administrator that is near the bathroom can actually be told that it's happening and be able to go there. So it's not too hard to have manpower for it if each teacher has the device on a walkie-talkie.
So you say that your cost of goods for $150, what you're selling for competitor $2,000. Are those like products? There's some difference between the two? That's a large difference between the two.
Yes. So from our further research, the products are quite similar. Some of the products, I forgot the name of the product specifically, but they do have similar qualities as ours. But ours is the only product that has, like, you can span the length of the sensor in the bathroom, and you can have an adjustable sensor for sensing the particles in the air.
What are your plans to do with the proceeds if you sell them?
They are going to go back to the schools. And then along with that, we were also thinking about taking this outside of the school and creating our own business as our CEOs and like have our own tiny little business. And so we were going to create the profits, and we were going to start making the product better and receiving more feedback.
I do. I wasn't really told to say this, but my father has actually worked with Newark in high school, and he actually helped them develop something, so they can be trusted.
Any other questions? All right, thank you. Good job. All right, I'm going to welcome our last team for this afternoon. This team will be representing Elizabethtown City Schools, and they're going to be talking to us today about garbage to garden. So let's welcome the team to the stage.
Good morning. My name is Levi Blevins.
I'm Jacob Hare. I'm Dylan Kerr.
And we are from Elizabethtown High School, and our Altec challenge for 2022 is garbage to garden.
U.S. landfills contain about 139.6 million tons of waste, 31 million of which is food waste. U.S. schools contribute about 530,000 tons of said waste. And this is where garbage to garden begins.
So our idea is to put 8 compost bins to our school's cafeteria, where our students can easily deposit of any decomposable waste that we produce. Our school roughly produces 7,200 pounds of trash daily. That's about the weight of an elephant for comparison. Roughly 1,400 pounds of that is compostable material. Worldwide, we put 31 million tons of trash. We produce 75% of that is compostable material.
So we would need some steps to make this possible. So the first one would be to gather the material from the trash can. We would have individual composting bins around the trash cans now to collect the unwanted material. We would then transport it outside to a greenhouse, and then we would mulch it and grind it into a finer material for faster composting. The next stage would be to tumble and water daily to increase that processing speed. Lastly, we would extract the new material and then store for later distribution to local farms and communities that need it.
Like Levi said, it will first go into the mulcher. It will turn it into mulch, the compostable material. And then that compost will go into the tumbler. It will be tumbled daily. And then that eventual compost will go into the greenhouse. That greenhouse will eventually be used to grow crops.
To rid the compost of any impurities, we'll be using live mealworms in order to rid of the compost as plastic. We will then use large rolling bins to transport the compost from the cafeteria to the greenhouse outside. Then we'll be using Durasacks to contain the compost till later use.
Then we will have 44-gallon trash bags, all about 40 pounds worth of material. These bags are biodegradable, so we don't have to worry about actually getting rid of the bags or bringing any extra waste. And then on our bins here, we will have wheels on the bottom of them to make transportation easier.
So we keep talking about these bins. So for our Altec challenge, we went into Autodesk as a group and created these custom bins to fit our standards. They all would be made from laser cut aluminum that would be rigid, rust-free, and also inexpensive. It would also be lightweight and easy to transport. The external bin would be 30 by 30 by 25. This would also contain wheels in the bottom, like Jacob said, and we'll create some type of label to display what the compost bin is for and the purpose of it. The liner inside is a second layer of protection. Like Jacob said before, we will have some type of bags to hold the compost, but this is an extra layer. Since welding aluminum doesn't always clear any holes, this will prevent any leaks or spills that may occur. And then the lid, of course, on top will display information of what can go on compost and educate the students on what will be necessary for compost, what not to add, things like that. So it is it's a very sustainable item. So here's our budget. Looking at it, we roughly use about $5,700 at the moment. The only thing we don't contain is the bins themselves from Altec. We talked to Haley Porter and the Altec team, and we're getting back on them on the prices for that. But at the moment, our largest expense would be the greenhouse. As soon as we get that information from Altec, we will get that information to you. But our budget is fairly simple. I know for a fact with any expenses for damages to the greenhouse and things like that, we know that this will be under $10,000. At the moment, we have it scaled to maintain itself for about 3 months. I know the bags are a thing we would need to purchase occasionally, but at the moment they would withstand about a month's use.
By starting small at EHS, we'll be able to use the EHS Environmental Club as well as Beta Club for volunteer hours, so we don't have to worry about labor or anything. And then after proving our efforts, we plan to expand on to other schools in the area around the community.
So throughout the months of process that we've had, we've talked to excellent engineers and received great feedback from them. We've talked to 3 Altec engineers, Haley Porter, Trevor Liebel, and Matt Norman. All received great feedback and information to reach out and talk to other people about. We talked to Caitlin Thomas, the Dow engineer. She recommended the compostable bags, and the 80 Games Vice Principal from the County Industrial Foundation was very helpful as well, reaching out to farms and communities that would use this. We are all very thankful for their information, and we would like to thank them for that.
Thank you. And if we are fortunate enough to win $10,000, we will take your garbage to our garden.
All right, any questions for the team?
Have you thought about how you might work with those farms? I'm sure there's a lot of time that would be involved in selling the compost once it's created. So what would that look like for your team?
So the time frame, if we do compost with the shredding and the watering, that would take a normal composting stage for about a month to about 2 weeks. So we would output it quickly. The farms would then use our material and spread it on crops. And we can even reach out to local businesses like, I think, Brewgrass Landscaping Company. They do composting too, or they would accept it, so we contacted them as well.
Have you secured your location at the high school where the greenhouse would be, and what other uses will it be used for?
Yes, we have. So at Elizabethton High School, we have a baseball field, and next to that is a batting cage area. I went on Google Earth and drew out a rectangle of the square footage that the greenhouse would need, and it is perfect size, and even more room for expansion if needed. I know that the greenhouse has 192 square feet. We would need 1 tumbler, the mulcher, and then the 2 yard bags, which would take up the area inside, which has plenty of room for expansion and potential grow beds too.
You pointed out in your SWOT analysis the challenge of odor. How have you guys thought about addressing that?
So I know with odor, the only way to kind of neutralize that interior is with carbon. We could create some carbon bins to cover carbon lids to cover the cafeteria bins, and cleaning them out cleaning them out daily would help with that. I know with the greenhouse there is ventilation doors and windows on the top that would open and vent that out. And I know that with normal composting, if it's inside the tumbler, it won't leak as much smell as you think. From personal experience too.
Any other questions? All right, thank you. Good job, guys. Good job. All right, well, here's where it gets exciting. So the judges have been deliberating for the last little bit, and I know it's hard on them, very hard on them, but they've done a fantastic job of picking our top 3. So we're going to start with 3rd place. And as we do this, what I would ask is that the winners come up with either their teacher sponsor, their sponsor from their school, whoever it was. Come join me on the stage. We'll do a photo, and we'll give you your gift card, and then we'll end up with the 1st place winner. Okay? If I had a drum, I'd be doing a drum roll right now. Brian, you want to? Oh, there we go. Love it. All right, in 3rd place, coming from EC3, team number 8, e-cigarette detectors. Good job. Stand up here. Got room for everybody? All right. This is where you take photos. Okay. Congratulations, Team 3. Good job. Very good job. Good job. Good job. All right. Thank you all. Team 8. Okay, in 2nd place, coming from Elizabethtown High School. Welcome team number 7, Fell Fill Extruder System. Good job, guys. All right, smile for the cameras. All right, congratulations. Good job, guys. Good job. Okay, now it's the moment we've all been waiting for. Drum roll, please. Coming to us from Elizabethtown High School, team number 4, Waste Collection Boat. Tenacity and grit does pay off. Great job, guys. Good job. Good job. Hey, love to stick to it. It's a great job. All right, bring that check up here, Mark. You all hold that check. There we go. All right, everybody say $10,000. $10,000. All right, congratulations, guys.
My name is Missy Mills. I am the Project Lead the Way engineering teacher at Elizabethtown High School.
Okay, so congratulations.
Thank you.
I believe. This is your second year for this team to enter, right?
Yes, it sure is. Last year, when we got the information, didn't really know a lot about this, but last year we had 4 teams chosen in the top 10, and this year we had 4 teams chosen in the top 10, and this year we got first and second. Last year we got second and third. I love this innovation challenge because it gives my engineering students a chance to come up with something, build it, go with it. And just like the LaRue County students who come to E-Town to take my class that won this year, they started this idea last year and they got second place with it. So when we started talking about the innovation challenge again this year, they asked me, could we use the same idea? And I said, absolutely, I think it's wonderful, but you need to make it work. You need to take it as far as possible, build it, make it work, and that's exactly what they did. And now their hours of work, their effort, their never giving up has paid off as they've won today.
So perseverance definitely pays off.
Absolutely, and I'm so proud of them. They're amazing young men. They don't give up on what they've started, and you can absolutely see that today. It was proven. So last year, their idea was to collect trash, have an autonomous boat that collected trash. And last year, when we came to this, all they had was just 3D printed sides of the conveyor belt. But this year, so what they did, they took the whole idea and they put it together. So the trash comes up onto the conveyor belt. It goes into this collection bin. It is run by solar power that is stored in batteries. It's run by an app system. It has a docking station. It will travel around Freeman Lake about 10 feet away from the shoreline, and it will run. The trash will be picked up on the conveyor belt, put into here, and then it goes back to the docking station to be dumped out.
So now with this $10,000, there will actually be an actual working model?
Yes, absolutely. This is just their prototype that they built during the class, and so now now with the $10,000, it will be an actually full functioning boat that does this. Absolutely. Mm-hmm.
So we're the Boat Boys. I'm Carter Peace.
I'm Sage Garris.
I'm Colin Crossnow.
And I'm Tate Wooten.
All right. So this is the second year for you guys. Is this the same 4 that were here last year?
Yes, sir.
All right, and you came in runner-up last year, is that right?
Yeah.
So obviously that was a little disappointing, but it was still good at the same time. So you decided to come back, and so how did you improve on things from last year?
We improved a lot from last year because last year we just had a conveyor belt with our prototype,
and it wasn't near what it was this year, because last year the conveyor was actually made out of duct tape, and then it was glued with a bunch of hot glue, and then we 3D printed some walls, but they were falling apart. It was terrible. This year we have a full working prototype that we've used. We've fully 3D printed, and we have a lot of materials, and it even flows, it works, it runs completely fine. So we've made a lot of improvements, and especially with this $10,000, we're going to make even more and make a large-scale model that's going to work great.
So, as you just said, you're going to make a full-scale model or an actual working device, I guess. Who gets the job of doing that? Or are y'all going to work together to do that?
So we're all four going to work together in the spring. I'm a senior and Tate here's a senior, so we'll be leaving, and Conley and Carter will be taking on this project further. We should actually have it done by the time we're out graduated.
It'll be a lot faster.
So they'll just have to either expand it or maintain it.
Okay, so you're anticipating launch like sometime in the spring then?
Sometime in the spring.
Right.
We're going to start work as soon as possible, sourcing our materials and building the boat. We're all going to work together. We don't have specific jobs. We all understand it enough that we can do everything.
Okay, so what was the inspiration for this type of device to begin with? How did this idea come about?
So actually Conley here had an idea of just some type of automated system for cleaning up Freeman Lake Park. We took that a step further and said we don't want a lawnmower driving around picking up trash on the park. Let's implement this into the water because of, like I said, some microplastics, different concerns. So we took it there, and then, like I was telling the other interviewer, we had lots of help from Altec, and they helped us source some things. They helped us bring our ideas to reality. It's just much appreciated.
I'll add on to that. We also, when doing this, we based ours off of a Roomba, basically. When doing all this, you know how a Roomba works, how it has the sensors and it's self-automated whenever it's cleaning up. That's basically what this machine will do, but in the water, for cleaning up trash.
So hopefully this is going to be something that's going to be ongoing for years to come, way after you guys graduate, and there'll be something that future students can participate in, I suppose.
Yes, sir. We're hoping that this will go a long way, and hopefully after this first large-scale product that we make, it'll expand and just more and more will be built and just help the earth overall.